Hi guys, today we are going to discuss GCSE Mathematics 3D trigonometry. Using the triangular prism shown, calculate the length of AD. This is AD, so this is just using Pythagoras. Length of AD will be AD equals to square root of 6 square plus 9 square, because 6 and 9, they are perpendicular side of a right angle triangle AED. So AD is hypotenuse, so we add this square and then take the square root. So if we count, this will be 36 plus 81, and this is more of calculator work. You can do this with calculator, so it will be square root of 117. Okay, so that is square root of 117 and 10.8 cm. That's the answer for A. Now, okay guys, so we have AD is root of 117 or 10.8. So we write down here square root of 117. Now, how to get the length of AC? We have to make AC. Here we go. We see AC is inside the triangle ADC, which we already found the side AD is root of 117. So now AC is the hypotenuse of this triangle ADC. Now, so we will count AC. AC is the hypotenuse, so AC equals to square root of AD square plus DC square. That is equals to square root of 117, and we put square, so it cancel out, and DC is a 5 square. So then we'll have square root of 117 plus 25. That equals to square root of, this is calculator work, 142. Then we count with calculator, we will get 11.9. That's our answer for B. Hi guys, so now we are in question C. The angle AC, find the angle of AC, line AC makes with the plane CDEF. So this is our line AC, and the plane with the shade CDEF with the green, yellow. So the tips for finding angle between the line AC and the plane CDEF is, if we observe the line AC and the plane CDEF, the point C is already located on the plane and A is still not in the plane. So we have to project the point A in line AC to this plane CDEF. How do we drop that? So we project A towards this plane that is perpendicular projection. So like we are looking this point from up, and then it goes to here. So point A is projected perpendicular to plane CDEF, now into here. Now this is the projected line of AC. Now it becomes EC. Okay, this is the projected line of AC, now become EC. Now we already know that this is also a right angle triangle, as we take a perpendicular line. This yellow line is perpendicular towards the plane CDEF. So now if this is a right angle triangle, so the angle that we are finding is between the original line AC and the projected line EC. This is the angle that we are finding. Now the trick for this is, the original line is always become the hypotenuse, projected line is adjacent, and the perpendicular line towards the plane CDEF is always the opposite side of this right angle triangle. So then we can count the angle. So this is the note. Original line is always hypotenuse, projected line is here, EC is always adjacent, and perpendicular line to the plane is always the opposite side. So we are finding the angle between original line AC and the projected line EC. So then we draw this triangle and move this triangle AEC to here, and we have the theta in here. So the theta is, because we already know the AE is from the question 6 cm, and EC is from the 9 square plus 5 square, square root of 9 square plus 5 square. So we just take tan theta is equals to TOA, opposite, over adjacent. So the opposite is always the perpendicular line, and the adjacent is always the projected line. So perpendicular line over projected line. So theta is equals to tan inverse of 6 over square root of 9 square plus 5 square, that's 30.2 degrees. So that is the theta. Okay guys, now we are in question D. The angle of between line AC makes with the plane ABEF. How do we do that? So with the same idea that the line AC, and then we have to draw the projected line of AC, so which we see that the point A is already in the plane ABFE or AEFB. Now point C we have to project into this plane by dropping it perpendicularly to this plane. So this is the yellow line, perpendicular line. Then we will have the C projected to F. Alright, now we will have the projected line is now A from AC, original line become AF. That is our projected line. So then according to our tips is that original line is always the hypotenuse, and projected line is the adjacent, and perpendicular line is the opposite, and the angle that we are finding between the line AC and the plane ABFE is the angle between original line and the projected line, that is AF. Okay, AC and AF, that is the angle. Now I draw the triangle ACF in here, copy paste, and the angle that we are finding is here between original line and the projected line, and this is for sure a right angle triangle. How do we know? Because this is the perpendicular line projected to towards the plane ABFE. So this is the right angle triangle with the yellow and the green line is right angle triangle, and this is the hypotenuse. And as we said earlier that the angle we are finding is between original line and the projected line. This is the theta. So now we use tan is opposite over adjacent. So opposite is 9 over adjacent is root 6 square plus 5 square, that is AF is the hypotenuse of AE and EF, triangle AEF. So we count AF square root of 6 square plus 5 square. Then we have theta is tan inverse of 9 over square root of 6 square plus 5 square. That is, if we count with calculator, is 49 degree. That is so. And still tan theta is always the perpendicular line over the projected line. So it's the same as the C. So tan theta is perpendicular line over project line. So we hope it's clear. See you in the next video. Bye. Okay guys, today's discussion is conducted by Study with Tuition Online. We cater for all the subject and this program. Email us if you are interested to join with our online tuition. Subscribe and ring bell so you'll not miss any of our latest video as we keep updating daily, weekly, monthly. And check the link below down describe as there is free resources from grade 3 up to grade 12, and also calculus and for pre-course. Bye bye and see you for now. If you have any question, any difficult question, you can upload in Google Drive, send the link in comment section. We will see what we can do for you, and bye bye. And don't forget to give likes to the video, and it will encourage us to make more video like this. Bye bye, and God bless you.